Hello, this is Information Service Engineering, lecture number 6, putting it all together. This part will be the second part of knowledge mining and information extraction. And let us start with the concept of knowledge discovery. So knowledge discovery is a non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data sources. So let's see one by one those concepts, what they mean. So by valid, they should be valid to a certain degree, so that the discovered patterns should also hold for new, meaning previously unseen problem instances. They should be novel, at least to the system and preferably to the user as well. Potentially useful, so they should lead to some benefit to the user or the task, and ultimately understandable. So the end user should be able to interpret the patterns either immediately or after some post-processing. So there are two main goals here for knowledge discovery. First is the descriptive modeling, which explains the characteristics and the behavior of the observed data. And then we have the predictive modeling, which predicts the behavior of new data based on some model. And the important thing we should get here is that the extracted model or pattern does not have to apply in 100% of the cases. And let us see the whole process now of knowledge discovery. Of course, we start from the data. Then comes the selection step, where we select a relevant dataset or we focus on a subset of the dataset. We don't have to deal with all the data available there. Then comes the pre-processing or cleaning step. This is a very important step that we need to have here, and it might end up being a bit costly. So here we have the data integration from different sources and the data cleaning. Then we have the transformation step, where there we select useful features, we do feature transformation and dimensionality reduction. And then we have the data mining, where we search for patterns of interest. And last, we have, of course, the evaluation, where we evaluate patterns based on interesting measures and we do model validation. So, we spoke about data cleaning in the pre-processing step. So this is something that we've seen before in the course of these lectures, but what do we mean with dirty data? We probably mean erroneous, noisy data, data that they contain dummy values, absence of data, or contradicting data, which it should be nice to fix and pre-process before starting any data analysis. And here we have some steps for data cleaning. First comes the parsing, where locates and identifies individual data elements in raw data. Then comes the step of correcting, where it corrects these parsed individual data components using sophisticated data algorithms. Then we have the normalization step, where there we apply conversion routines to transform data into a standard format. Then comes matching, where we search and match records within the data based on predefined rules we have. And last comes the consolidating, where we merge data into one common representation. These are the steps for data cleaning. Let's see now some of the functionalities of knowledge mining. So we can do characterization, which is the process of summarizing general features of objects in a target class. Or we can do discrimination, which is the process of comparing general features of objects between a target class and a contrasting class. We can do association, which is the study of the frequency of items occurring together. We can do prediction, where it's the process of predicting some unknown or missing attribute values. Classification, which is the process of organizing data in given classes based on attribute values, and in this case here, this process is supervised. Or clustering, which is the process of organizing data in classes based on attribute values, and here it's unsupervised, as we have already seen before. Then we can do also outlier analysis, which is the process of identifying and explaining exceptions. And last, time series analysis, which is a process of analyzing trends and deviations. As you already know, in this lecture we focus on prediction, classification and clustering. So we spoke about data analysis. So what data analysis is? Data analysis is a fundamental iterative process that has the following steps. First, we formulate and execute a query. Then we analyze the results that we get from this query, and then we formulate a new query based on the already achieved results. And this, as we said, is an iterative process. And the goals of data analysis are the following: to maximize understanding of analyzed data, to uncover hidden structures and patterns, to extract important variables, detection of anomalies and outliers, testing of a hypothesis, and last, of course, development of a simple model, as we always want to do. So, hands-on. Here we are going to do now an exercise, an example of a data analysis task. And you see here this figure with a soccer player. So we are going to have a similar to the previous task. So we are going to analyze several attributes and characteristics of soccer players. So we have to pick our data set, and for this example we are going to do it using Wiki data. In the previous one we used Wikipedia, now we will use Wiki data. So as we said, our very first step is to examine the available data. And what do we do here? We are going to pick an example, which is a representative example of the type of data we want to use, and examine and see what is there. So here you see a screenshot of the Wikipedia page of Lionel Messi, a very famous soccer player here in Europe. So what do? We go to this page of Lionel Messi and check what is there and what can we extract and analyze. So here you see a closer look. Okay, you see here that we have again a statement and the qualifiers in the statement. Just a small recap here in Wikidata. This is a particularity of Wikidata, of how they structure the knowledge. You remember we had a lecture about it. So we have the statements and the qualifiers that they apply to the specific properties. And what we should be careful here on is the different namespaces used in Wikidata for the different type of properties they have. So for example, we have the WDT namespace that connects an item to a value. So if we want to get this Barcelona entity, which is the team that he played, he was a member in, we are going to do it using this WDT property P54, and we get the team. The P namespace connects a subject to a statement, so this is how we access then the statement itself. So you see how we do it here, WDT, the WD, the soccer player P54, and then we access the team statement. And from the team statement we want to get information that is there in the qualifier. So for that we are going to use the PQ namespace, which connects a statement to a qualifier value. So this is how we have access then to the number of points, goals that he scored there, which is something that we want to use in our analysis. So this is how we get it. So then we have to compose our query in order to get the data. And this is the query we are going to ask in Wikidata. You see first we have all the select statements, where you see here a sum of goals as total goals, because in the end we want to get all the goals for each specific player in any, no matter in which team he was part while he scored that goal. Then we get the height, the weight, the position label, and the birth date of the player. And you see here our query. So S should be a type, I suppose, or has an occupation soccer player. Then we access the team statement. Then we get the height for the player, the weight, the position, and the birth date. And since we access the team statement, from there we get the number of goals, the goals that he scored. Here we see that from the position label, from the position actually we want to get the label and not the URI, so that it's easier for us to handle it. And there is just a filter here that this position label we want it to be in English. And in the end, group by its soccer player. Okay, so far so good, I suppose. This is we've seen before a similar query. So what we should do, we should go to Wikidata and ask our query. So if I click on here, we transferred immediately to Wikidata, and we are executing our query. So if you execute your query, it probably will take a couple of seconds. You are going to see this example, these results here, the different attributes with the values we asked for. And as we said also before, this you can export it in a CSV format. And if you do that, you can then import it directly to a Google spreadsheet and process it accordingly as you want. So if you go to that link, this is the Google spreadsheet that contains all this information we got from our query to Wikidata. And actually we didn't stop here. We did some cleaning or pre-processing steps for you. So this is also the cleaned or pre-processed version. For example, we separate also the year of birth from the birth date, so that we can do some statistics based on the year that the football players or the soccer players were born. I removed some outliers and fixed some errors. So if you want, you can go play with it and check if you find more errors and more ways to fix even better the data. You can have access in both raw data and cleaned version of data. So up to this point now, we have gathered our data and cleaned our data, and we are ready for our analysis. In this analysis, we are going to use box plots. So box plots is something like the one that you see here in the figure. So it's a box that gathers all these values of a specific attribute, let's say. Before, you should have done an analysis on the data themselves before building the box plot. Here, as you see, this line is the median value there, which is different from the mean value. So you know that the mean value is like the average of all values we have, while the median is the value in the middle position if we sort our values. So if we have 10 elements there sorted, median will be the value of the element in the 50th position. And you see also that we have the minimum and the maximum value here. So here in the box plots, the area inside is called interquartile range, or IQR, and the one on the bottom is called always the first quartile, while the one on the top is called the third quartile always. And in there we have the 50% of the data already, of the values already. And another thing that we have here in the box plot is the whiskers. You see here, this is the how we compute the whiskers, is the IQR, or interquartile range, multiplied to 1.5, and we compute the bottom whisker and the top whisker, and in between those whiskers now we have the 75% of our data. And what is out of it, you see on the top, are the outliers, are values that they are outliers. This is more or less how they work, the box plots. But it's not only that we can do further analysis with the data we have. We can check about distribution. So here you see we have computed the distribution based on the height, on the total number of goals, of the weight, and of the year. So you see there are quite some things we can do here. So in the next part of the lecture, we are going to see how to produce actually all those statistics using Python.